Okay, we're going to take a look at some operations with radicals now. Here are some complete examples. We'll go through combining like radicals with addition and subtraction, combining unlike radicals, so we're going to be using simplifying in order to combine radicals that at the start don't look the same. And then we're going to be doing some multiplication with radicals. Now I might need to pause the video for a second before we multiply, but we'll see how that goes. Okay, so when we're combining like radicals, as in these two examples here, what we're doing is we're combining the number that is with the radical, okay? So if our radical is the same, we almost treat it like as if it was a variable, okay? So the radical doesn't change. The radical will end up staying the same, but we do combine the numerals, we do combine these numbers here that is in front of the radical, okay? So 4 root 3 plus 6 root 3 is equal to 10 root 3, okay? Now it's the same here. Even if we have, in this case, we have radicals that have an index of 5, and the radical is 4xy squared. Okay, so we have 6 4xy squared to the fifth root minus 4xy squared to the fifth root. Okay, so we take our 6 minus 4 here, and so it's 6 minus 4, and then we keep the same radical that we had above, and so our solution is 2 4xy squared to the fifth root. Okay, so we'll get some more examples over here. In our first example here, we have 4 root 3 plus 5 root 3. Okay, like I said, we kind of think of these, treat them similarly to how we treat variables in this case. So if we have 4 root 3 plus 5 root 3, then what we have as a solution is 9 root 3. Okay. Now, if you have several terms that are together, such as in this case, we're basically combining like terms. Okay, so here we have a negative 2 root a minus 4 root a. So this is negative 6 root a. Over here we have 4 root 7b plus 9 root 7b. Okay, so we have 9 and 4, which is 13 root, whoops. Oh, I'm going to have to move that over. Sorry. 13 root 7b minus 6 root a. Okay, so anytime that we have like radicals, we combine like terms. Okay, so the like radicals, we combine the number in front together, like we did here. 4 7 root b plus 9 7 root b, and negative 2 root a minus 4 root a. All right. Now, in the case that we have radicals that are unlike, okay, here we have a couple of examples where the radicals are unlike. Okay, so the first thing that we have to do is we have to simplify each of the radicals. Okay, when we're simplifying radicals, remember what we're doing is we're factoring the number that's within the radical, okay, by considering what the perfect square factors are. Okay, in this case, 18 has a perfect square factor of 9, okay, and that's 9 times 2. All right, now, because there's no number written up here for the index, that means that it's a square root, okay, so it's to the second power. So if you remember back to perfect squares, x to the fifth is not a perfect square. Perfect square exponents are multiples of 2. So I know that x to the fourth is a perfect square. Okay, and that means if I have x to the fourth as a perfect square, I have 1x left over. Okay, so I'll leave that there for just a second, and we'll come over here. So it'll be plus 2x. Okay, now we need to consider perfect square factors of 50. So I know that 25 times 2 because 25 is a perfect square factor. 25 times 2 is 50. Okay, again, there's no index here, so I know it's a square root. Okay, x to the third, also not a perfect square, but I do know that x squared is a perfect square. Then I have 1x left over. Okay, now it sometimes helps to identify somehow our perfect square factors. Okay, these are both perfect square factors. So if I square root both of those perfect square factors, what I have is 3x squared. And then within my square root, within the radical sign, I still have 2x. Okay, now let's come over here. Plus, oh, this one's going to get a little tricky. Okay, because whatever I pull out here, whatever I pull out from here, I'm going to have to multiply by this. So for right now, I'm just going to leave that as multiply. Okay. Now my perfect squares here were these two. So 25, square root of 25 is 5. And then the square root of x squared is x. Okay, so within our radical, we still have 2x. Okay. All right, so now what we said is that since this was being multiplied by what's in your square, what's in the radical sign here, we have to multiply these two together. Okay, so I think I'm going to need a little bit more space here. Okay, so I'm going to rewrite my 3x squared square root 2x, and then up there the 2x times 5x will be plus 10x squared, and then root 2x. Okay, so now if we look at what we have here, we have like radicals. Okay, we have square root 2x, square root 2x. Okay, this one is 3x squared plus 10x squared. So that'll give us a sum of 13x squared square root 2x. Okay. All right, let's do one more of these. So when we're looking, I'm going to probably do this. When we're looking at radicals that are unlike, we have to start first by factoring the radicals so that we can, by factoring the radicands in order to simplify the radicals. Okay. All right, so let's take a look at this one. 27. Now we see in both of these radicals there's no index, so that means that they are square roots. Okay, 27 has a perfect square factor of 9. So 9 and 3. Now x to the 7th is not a perfect square. However, I know that x to the 6th is because it's a multiple of 2. And then I have one more x. Okay, plus 2x squared. Now we're looking at the 12. Has a perfect square factor of 4. It's 3. Remember we said x to the 3rd is not a perfect square, but x squared is. And then we have 1x left. Okay. All right, so coming over here, our perfect squares. I'm just going to go through and underline all the perfect squares right now. Okay. All right, so let's go back here. So square root of 9, I'll write it down here, is 3. Square root of x to the 6th is x to the 3rd. And then we have 3x left over. Okay, and this term here, we have, I'm going to write this first, 2x squared, and then remember we need to multiply. So square root of 4 is 2, square root of x squared is x. So 2x, and then we're going to have square root of 3x. Okay? All right, so now this one, remember we have to multiply this. Okay, so 3x cubed root 3x plus 2 times 2, 4x cubed root 3x. Okay, now we have like radicals. Okay, so we can combine what we have in front of the radicals. All right, so this is 3x cubed. Because it's a like term, 4x cubed, we can combine those. So we have 7x cubed square root 3x. Okay. All right. I'm going to start another video for multiplication. So just again, here is this right here, so you can take a look at it. I will show it also at the beginning of the multiplication video.